Hey guys, welcome back. So this week we're going to talk about the lymphatic system, and so we're going to do notes today, work on your study guide tomorrow, look at some disorders, and then have a quiz for you all at the end of this week, which will open again on Wednesday, close on Thursday again. So great job overall for turning those quizzes on time. Um, and so we're just going to kind of go through this and crank this out. And we'll label some pictures at the end, and that'll be it. And I'll have your study guide posted today as well, um, just so that you guys can work ahead if you need to. So, what we're going to do first is we're going to talk about the lymphatic system. I'm going to do some purple today. I think I made these blinks a little bit too big, but that's okay. It's going to consist of two semi-independent parts. So semi-independent, they are not fully independent of each other. They work together but separately at the same time. And so when we talk about this and we look at these pictures later and how this all relates, and then you will see and understand all of the semi-independent parts of this. So this is a network of lymphatic vessels which transport fluids escaped from the blood back to the blood, and then various lymphoid tissues and organs house the cells to play central roles in the body's defense. This does not want to scroll up. There we go. So our lymphatic vessels, we have fluid that escapes the capillaries and not reabsorbed by venules. And this is as much as about 3 liters daily, which is a lot of blood. And so this is why the lymphatic system is very, very important, not only for what we're going to talk about later, but also for trying to put blood back into the body or back into the blood vessels, which comes a part of the interstitial fluid, which is the fluid between cells. And so this fluid needs to go back to the vascular system. If not, what we call edema or swelling occurs. And so you see a lot of edema with injuries, but you can also see a lot of edema with patients who their lymphatic system is backed up or they're not doing a lot of, their lymphatic system is not working properly. So the lymphatic vessels pick up excess fluid, lymph, and return it to the bloodstream. This is an R. So let me rewrite that. There you go. Now, lymph, if I can spell it correctly, guys, there's no T. I'm sorry. It's primarily water and a small amount of dissolved proteins. This is what it's contained within these lymphatic vessels. And it is a one-way flow of lymph in vessels towards the heart, and there is no pump here. Now, fluid is forced along the vessel. Then we have what we call lymph collecting vessels, which are kind of like how we do within our veins, is where a skeletal muscle contracts, blood flows through the body, same type of thing here. And so we're going to collect lymph from its lymph capillaries, where it carry lymph to and away from lymph nodes, return fluid to the circulatory veins near the heart. And we do this through the right lymphatic duct, which drains the lymph from the right arm and the right side of the head, the thoracic duct, which receives lymph from the rest of the body, and both ducts empty into the subclavian vein, which then goes into the heart. Now we have our lymph nodes. What are lymph nodes? And so what they are going to do is they're going to help protect the body by removing foreign materials such as bacteria and tumor cells, defense cells within lymph nodes. And we have our macrophages, which we talked about previously within cell types, and lymphocytes. So our macrophages engulf and destroy foreign substances, while our lymphocytes provide immune response to antigens or non-self things. For instance, one of those things would be like a different blood type. So as lymph is transported back to the heart, it is filtered through thousands of lymph nodes and clusters along the lymphatic vessels. Large clusters are found in the inguinal, axillary, and cervical regions of the body. Harmful materials enter lymph vessels, bacteria, viruses, cancer cells, and cell debris. Or in this case, like we go through apoptosis of cells, and that debris is being collected so we can recycle those. So a misnomer is swollen glands. These are not glands of the endocrine system, or in this case, the hormones. These are nodes of the lymphatic system. For instance, you have strep throat. You feel if you have your tonsils are swollen. That is part of the lymphatic system, not the endocrine system. So while lymph nodes help get rid of infections, agents, and cancer cells, they become overwhelmed. Now, a large number of bacteria and viruses trap the lymph nodes so they can, and causing them to become inflamed and tender to touch. But this also allows these white blood cells to come in and fight off these infections. We can also become secondary cancer site. Cancer-infiltrated nodes are swollen but not painful. This helps to distinguish between those cancerous and those simply infected by microorganisms, aka viruses and bacteria. So now we're going to talk about some lymphoid organs. We first have the spleen, which curves around the stomach, an organ that filters blood, acts as a blood reservoir, destroys worn out red blood cells, and produces lymphocytes, and forms blood cells in the fetus. And so, oh, I forgot to write, that filters blood, acts as a blood reservoir, destroys worn out blood cells and produces lymphocytes, and forms blood cells in the fetus. Now, within the spleen, it's very, very important because for a disease called mono, you guys probably know what mono is. Spleen is usually what's infected, and so a lot of people actually have a swollen spleen or even a spleen that ruptures. And so this is very, very important to the body because of the part of it filters that blood. It acts as a blood reservoir. It stores blood when needed. And so you actually have to be very, very careful with your spleen inflamed or post spleen ruptures due to the fact of you do not have that blood reservoir anymore. You do not have that filtration of your red blood cells. So now we have the thymus. So it's located in the low in the throat. It's overlying the heart. It's most active during the youth, and it matures the T lymphocytes by secreting thymosin. Now remember, the thymus also works with the endocrine system. So kind of put those together. So now we have the tonsils. This is the ring of the pharynx and the throat. It's going to trap and remove bacteria and foreign pathogens entering the throat. They become congested with bacteria, become red, swollen, and sore, or what we call tonsillitis. And this is why you see a lot of tonsils being pulled from or being removed from children below the age of like 10 to 12 years old, is because they consistently have swollen tonsils and swollen tonsils and swollen tonsils due to always being sick, because kids are basically what they a lot of times they carry just a lot of bacteria and infections, and so they're always sick. However, a lot of times you don't know unless their tonsils are swollen or they have a fever, and so a lot of times they go hand in hand. Um, and so within this, it becomes more of a hindrance to their growth and development because they're not able to eat and um, take in the material needed in order to grow and develop. And so, therefore, they remove tonsils for the safety of the child, which then returns as they get older. They are not able to house that bacteria and keep it out of the body to be able to kill it. So then we have the Peyer's patch. And so this is found in the wall of the small intestine, and the macrophages that are stored here capture and destroy bacteria within the intestines, which is very, very beneficial for us. So now we have the body's defenses here. So the body is constantly in contact with bacteria, fungi, and viruses. The body has two defense types for foreign material. We have non-specific and specific, or the non-specific would be the innate and the adaptive for the specific. Well, again, can't spell. I'm sorry. There we go. Adaptive. Then we have the immune-specific resistance to disease. Now, we have innate defenses, which is our non-specific, and it refers to the mechanical barriers. In the first line of defense, that should be an S, that covers the body surfaces and to cells and to chemicals, which is the second line of defense that acts on the internal battlefront to protect the body from pathogens or what we call harmful or disease-causing microorganisms. So, for example, our first line of defense is our body system coverings, would be our skin or mucous membranes. The pH of the skin is acidic to inhibit bacteria growth, so we don't have this bacteria just growing on our arm just for kicks and giggles. And then we have our sebum, which is our skin oil that is toxic to bacteria. Then we have our vaginal secretions that are very acidic. And then our second line of defense, we have our phagocytes. Then we have our natural cell killers or lice, which kill cancer cells, destroy virus-infected cells. Then we have our inflammatory response, which occur when the body tissues are injured. And so this is what happens specifically after cuts. Your skin gets really red and inflamed or swollen due to this inflammatory response, which is in these four categories: redness, pain, swelling, and heat. Now, if these are more than about a week old, you probably need to get it checked out to make sure it's healing right. Especially if the cut is still oozing after about a week, that would mean it would probably be infected. It takes up really about a week to get a layer of skin there, or in this case, a scab to hold, because a lot of times we're active even after cuts. And so we want to make sure that we don't reopen these because that would increase the infections. So then we have antimicrobial proteins. They attack and hinder reproduction of microorganisms. We also have antimicrobial, or what we call neosporin, that we put on cuts as well. This also helps attack and hinder reproductive of microorganisms to help us protect our body as a second layer. So then we have fever. It's abnormally high body temperature. Hypothalamus heat regulation can be reset by pyrogens, which is secreted by the white blood cells. So if we have an increased amount of white blood cells in the body, it tells the hypothalamus to, hey, we need to keep it hot in the body. So the sole purpose, we do not keep having spread of pathogens within this body. So it starts to kill these pathogens or the microorganisms, so they don't keep infiltrating the body and keep reproducing. They're also increasing the speed of tissue repair as well, which helps specifically for cuts. So now we have specific adaptive body defenses. And this is the third line of defense. I'm just going to leave it because apparently I have just killed it today. So, stalks and eliminates almost any type of pathogen with an immune response to a threat or immune response targeted to a specific antigen or non-self. There are three aspects to adaptive defenses. First, we have antigen specific. We have systemic. We have memory. Now, specific or antigen specific recognizes against particular foreign substances. So within these cells, they have certain carbohydrate markers that tells you they are shapes, but they're micro shapes on what this cell is. And so if it does not meet that requirement within the cell, it says, all right, we have an invader, let's attack it. Now we have systemic. It is not restricted to the internal infection site. And we have memory, which is recognize the amount of stronger attacks through previously countered pathogens. And so our memory is where we have what we call vaccines. So within this, we give a small amount of DNA or RNA and says, okay, this, we got to fight this, and we see it. So it stores it within what we call these mast cells. These mast cells hold our antibodies that fight off diseases. And so it stores them in there. And when it recognizes that code again, it says, all right, mast cells explode. Antibody goes into an attack mode to where we kill it off to where we get less serious effects of these pathogens or microorganisms. So now we have types of immunity or immunity. So we have humoral immunity, which is antibody-mediated immunity. Antibody is present in body fluids. We have cellular immunity, which is cell-mediated immunity. This targets virus-infected cells, cancer cells. And then we have antigens or non-self, which any substance capable of exciting the immune system and provoking an immune response. And these are nucleic acids, large carbs, some lipids, pollen grains, microorganisms, foreign proteins, which is the strongest. So we have cells that are of the adaptive defense system. So we have lymphocytes, which originate in the immunocytoblast in the red bone marrow. We have the T lymphocytes, or what we call T cells. They identify specific foreign antigens. They become immunocomplacent in the thymus. We have the B lymphocytes, which produce the antibodies that become immunocompetent in the bone marrow. And then we have the macrophages, which help lymphocytes come from a monocyte and engulf foreign particles, or I call them the eaters of the immune system, because they basically eat anything and destroy it. So we have disorders of immunity. We have allergies. This is the one that we're about to start hitting within, since we're in March and it's starting to rain and things are starting to produce pollen. And so these are abnormally vigorous immune responses to which the immune system causes tissue damage as it fights off a perceived threat. So a lot of this is with pollen that we have. Also, we have food allergies as well. And so the term allergen is used to distinguish the type of antigen from those producing normal responses. But then we also have immune deficiencies. And so this is abnormal immune system function, which may be congenital or acquired. And so our first one is a congenital one, is SEID, which is severe combined immunodeficiency disease. And this is what we call the bubble boy. So if you don't know who the bubble boy is, basically this kid or the poster child of this had a deficit in both B and T cells, could not fight off any system at all, because if we look back previously, our T cells identify specific foreign antigens, and our B cells produce antibodies. So we had no way to fight off diseases. And so basically this boy lived in a bubble because of the part of it cannot be exposed to the outside world, because there would be no reaction to it. And so the common cold could kill the child. Our last one, or our last one we have is AIDS. So this is an acquired, and this is due to the acquired immune deficiency syndrome, and this interferes with the activity of T cells, specifically the helper T cells, which allows us to be able to bind to things that are microorganisms to say, hey, let's go, let's fight this off. And so most people who have AIDS do not die from AIDS. They die from another disease because of the fact that the helper T cells do not allow them to do their functions so the person can fight off the disease. And usually you see a lot of the death within disease called pneumonia within this, because they're usually bedridden through another disease. They get fluid in the lungs and they die. So then we have autoimmune diseases. And these diseases attack and damages its own body. So for example, we have some here. So we have multiple sclerosis. We have Graves here. We have Graves' disease, juvenile diabetes mellitus. We have lupus, rheumatoid arthritis. And we have glomerulonephrititis, which is impairment of the renal function. So make sure that you guys know those. I'm pretty sure they're on your study guide. And then we have organ transplants and rejections. So essentially there are four major types of grafts. We have autografts, which comes from self, because auto means self. We have isografts, which is from genetically identical person, or in this case, an identical twin. We have allografts, which is taken from another person, and xenografts, which is taken from a different animal or species. So autografts and isografts are ideal donors, while pig grafts have been transported with success, which we call xenografts, xenografts are virtually never successful. And then after surgery, to prevent rejection, we receive immunosuppressant therapy. Now, we're going to label these below. You're going to have to draw a picture, or label a picture probably later this week as well. We have tonsils, spleen, thymus, and pyrus patch that I put in here. Now, your tonsils are more within the posterior of the throat and also into the neck. It looks like they're at the mouth, but they are not. That's just the way the two-dimensional shape of the picture put it there. And then we have here, so like these would be our tonsils back here. Here we've labeled these as well with our subclavian vein, our lymphatic vessels, our lymph nodes, our inguinal nodes, our thoracic duct, our axillary, which is armpit, and cervical nodes. Now, I'm going to zoom in real quick for y'all. What I just circled there, that is my lymph node. The vessels are they look literally like vessels from our arteries and veins, which are these right there. So make sure that you guys are able to recognize the difference of those. And that's our notes for the day. Make sure that you turn in the notes this evening so that you are able to get the credit for it. And I will also push your study guide today as well. So you want to get a head start. That's going to be what we're working on tomorrow. And I will see you guys on Tuesday/Wednesday this week. And I hope you guys have a great day.